the only constant in software is change.
Welcome to the MongoDB podcast. I'm Nick Raboy, and I'm with my co-host Mike Lin, and we're going to be talking to Kenn White, security principal at MongoDB, about MongoDB security. So we're going to be talking about things such as field-level encryption, encryption of your data at rest, some best practices that you can use to make sure that you're in compliance with certain regulations. We're going to have a pretty much great time when it comes to overall security practices that you can take.
All right, so we're here with Kenn White. Kenn, it's really great to have you on the show. I'm really excited to chat with you about all things security at MongoDB. Can you start off by introducing yourself to the audience?
Sure, thanks, Mike. So I'm Kenn White. I'm a security principal at MongoDB. My focus is generally around encryption and security for our cloud platform and most of our global product group. So lots of interest in different areas of security across the board.
Oh, that's great. And how long have you been at MongoDB?
So I'm about at the 2.5-year mark. So yeah, been a little bit of an old man, I guess, in Mongo staff terms.
Yeah, you've seen some good stuff, though, over that time period. It's been quite a ride. I've been here 4.5 years, I suppose, somewhere around there. And just in terms of security, it's amazing to me how far we've come. So you've seen the advent of MongoDB Atlas, right? Where did you come in terms of, when we launched Atlas?
Right. Yeah. So when I came in, Atlas had only been the database as a service offering had only been really, I think, available for about a year.
Mm-hmm.
So it's pretty remarkable. It's gone from kind of a niche offering to now it's something like 45% of the revenue of the company. So lots of interest in people sort of focusing on the development work and kind of offloading the heavy lifting of infrastructure for the folks who built the engine. So yeah, big change for sure.
So I want to dig a little deeper into the scope of what you manage as a security principal at MongoDB. So you mentioned the cloud platform and some of the products. I just want to get into the specifics so that way the listeners can get the context of your scope. So, for example, do you have oversight into, say, the on-premise versions of MongoDB or the drivers, or maybe just shed some light into that?
Sure. Yeah. And I have to sort of preface this by saying I've got kind of an unusual role. I'm not a product manager, so I'm not. I don't work on the the marketing and promotion side, but I report into the engineering group. So I've helped to kind of shepherd a few products along, a few pieces, a few features of the of the products, but it's not. It's much more sort of purely security focused. So any given day I could be working with our senior engineers, scoping things out for some new feature coming down. I could be working with strategic customers on some really interesting or unusual problems, trying to create some solutions. Could be talking to people in the media, or working with journalists who had questions and things, or could be working directly with developers. Some days I'm developing code and doing like demonstrations and things like that. So I kind of wear a lot of different hats, but kind of have visibility across quite a few areas. On the one project I've been working on for a couple of years, and I'm sure we'll get more into this later, is the client-side field-level encryption. So for that one, I was kind of the product architect, and happy to talk more about that, kind of as we go forward here.
Oh, we'll definitely get into that. That's a huge topic. I love the whole project around field-level encryption. But before we go there, how did you get into security? And you mentioned that you still write code. Give me an idea, like what's your background around code, and what drew you to the security side of things?
I have such a weird pedigree. So my my formal training's in computational modeling and neuroscience, and so I actually did a lot of work in the healthcare space and in the clinical world. And so when I was in grad school, I was doing a lot of work at the NIH Clinical Center outside of DC in Bethesda, Maryland, and it's just such an incredible place for kind of young engineers and scientists and researchers to kind of come along. But anyway, the short version of the abbreviated version of that is we were doing a lot of work around MRIs and not just the structural stuff, so the pictures of the bones and tissues and things, but also something called functional MRI, which actually looks at metabolism. So you can, for example, have people working on different reading or doing different kinds of cognitive tasks, and you could actually see different areas of the brain flow and activity levels like in real time. And so at some point I kind of realized I like the computer and the sort of the software side of that almost as much as the science. And eventually I kind of went sort of full-time into that. But yeah, so I have kind of a weird background. So it's partly like signal processing, image analysis, real-time processing. So, I was doing stuff that had to have sensitivity within like, microsecond kind of, response speed. So lots of embedded systems and that kind of stuff. And then somehow I kind of ended up in the clinical research world with drug development. So everything from like, psychiatric meds to cancer medications, new treatments, any kind of, drug therapies, and did like 15 years building, mission workloads around clinical trials. And at some point, we built up something like 2,000 centers around the world. I'd kind of ended up sort of architecting the core, system software, but then also kind of owning the security pieces of it. I've had some other roles too. I've done, I've been a CIO and a CISO, did some work with the military, did some work with Homeland Security. So yeah, lots of different kind of things that kind of sort of brought me here. In the last several years, I've been really focused around encryption. So I don't know if folks are familiar with the Linux Foundation, but it's it's a major nonprofit that sort of a lot of the open source world, coalesces around, in terms of funding and things. So the Linux Foundation created this thing called the Core Infrastructure Initiative around the time that Heartbleed broke out. And we worked with them to do, a full formal cryptanalysis on OpenSSL. And so that was an interesting project. And so I've kind of taken quite a few paths, but mission workloads, distributed systems, real-time network defense. That's kind of the very abbreviated version of a story of a strange career that brought me up to this point.
So it sounds like you're the guy to talk to when it comes to encryption, and I definitely want to dig in deeper to that soon. But before we even go there, I want to ask what kind of goes into the process of securing a platform like MongoDB? What are the different aspects of security?
Yeah, no, that's a great question. So a lot of these things are just kind of fundamentals. They're sort of like, foundation concepts. So the first thing is you have to kind of really think about what kind of information you're holding, what kind of information you want to protect, where that's going to live, and then, do some really basic threat modeling, like, who or what might be, potential risks to this data getting leaked out. If we're not holding, secure information, then maybe I don't really care. If this is something on a, if I've got a personal blog that's got, cat pictures, I'm not super concerned. If I've got things with healthcare data or PII, then, then I have to treat that very differently. But yeah, so I think like any database, you sort of start with the fundamentals: where are the sensitive data, what kind of information you're holding, who should have access to it. Is it mainly going to be people? Is it going to be systems? Is it going to be a web app, a mobile app? Is it going to be some kind of big system integration with like a enterprise system? So you kind of start with those questions, but then all the fundamentals that we're taught in security, the CIA triad, the confidentiality, integrity, and availability. Those are kind of the key pillars. So you got to set authentication. You got to figure out who's authorized to get access to the data. And sometimes it's really simple. You've got a simple web application that talks to the database, and that's the only user. In other cases, you've got thousands and thousands of different people users that are going to be connecting, maybe as analysts, maybe as some sort of reporting things. So you have to figure out what are the paths to get there. Then other questions are like, is this going to be an internal system? Is this an inside a corporate or an organizational network? Is this something that's going to be living on the internet, public facing? Because if that's the case, then you've got a whole different kind of approach and set of responsibilities you've got to kind of take care of. We lay a lot of these out in our security white paper, which is really helpful. It's got a lot of very like practical kind of prescriptive steps that people can make. But one of the things we focused on a lot in the last several years is making sure that, if you download MongoDB, whether you're on Red Hat or Debian or, Windows Box or whatever, or on your Mac, the default installation should be reasonably secure. So by default, you're not listening to the public, network traffic. And so, in kind of playground or sandbox mode, that works really well. We've got all kinds of things you could turn on to, around encryption and auditing and monitoring and things like that. But it's really kind of a structured, disciplined kind of step through what the kind of information you're protecting, where it's going to live, and who could potentially have access to it. If you've got sensitive information on an internet-facing sort of 24/7 open to the world system, then you have to be really careful and thoughtful about how you're going to be protecting that, and how who you want to have access to it, and so forth. We see these stories from time to time, whether it's Mongo or a caching system or a cloud bucket or something like that, where people have information and it gets picked up either by a search engine or maybe by an attacker, and then there's all kinds of problems that come with that. So really the responsibility is on the person who's owning the data. Like, what kind of information does it have? How are you securing it? How are you how are you protecting it? And then importantly, if there is some kind of unauthorized access, how do you know? How are what kind of monitoring do you have in place? This sort of thing. So there's several different levels, but a lot of these are kind of foundation. If you have sensitive records, you got to protect them. Period.
Yeah, I get that. I think so. What's fascinated me is over time the kind of switch in the vectors between MongoDB as a platform, as a database, and MongoDB Atlas as an online database as a service. So early on, the challenge was this dichotomy between making the database easy to use so that anybody could just install it on their laptop or desktop and off you go, and it's just easy to use and you can learn. But over time, obviously, rolling those play apps into production apps and making sure that you check all the boxes to make things secure on the way, that is a dramatically different story in terms of security than using a database as a service online. And the profile of vectors have dramatically changed. Can you talk a little bit about like the challenge between those two, servicing those two worlds, where we want the database to be as easy to use as possible, but at the same time we need it to be secure, and controlling those out of the box levels of security, and how that's changed over time?
Sure. No, that's great. So in the software world, there's this phrase called code smell, and what it means is you may not have a deep understanding of a particular language, but as an observer, so you take a quick look at code, there are a couple of kind of telltale signs that there's something probably deeper going on. It's kind of like if you were buying a car and you were looking at the options and electric windows weren't included. Okay, maybe you don't really care about electric windows, but the fact that they're not even included, if it's crank only windows, you may be looking at a 30-year-old used car. You know what I mean? Like, so there's sort of symptoms like that. In the security world, there's something similar. There's sort of a security smell. And so a lot of times what we find with developers is they do get up and going quickly, but maybe they're just on a single, a single node with no availability, no failover, no robustness. And then, you can sort of picture people kind of flipping different knobs to just sort of see what works. In the same way, if you install a web server and you get stuck at some point in the in the install process, and you say, all right, forget it, I'm just going to install this as root, and I'm going to set all the permissions on my Linux box to 777. Well, I guess that works in the sense that you can start your Apache or Nginx or whatever. The problem is if there's even the slightest vulnerability or flaw, then the attacker has instant access to the entire system. So
Nobody does that though. Nobody chmod 777s anymore, right?
Right, but and that's totally fine on your laptop, or if you're just sort of evaluating something to kind of quick and dirty, that's perfectly fine. The problem is that transition from that state to I'm playing around with some dummy data to the next step, which is, oh, by the way, here are insurance records for real people that are exposed, and like the security is just one of your problems. The other problems are, if anything at all happens to this cloud image, you're just you're out of luck and you've lost your data. So there's like a whole constellation of things. But yeah, so for the same reason, I think that a lot of customers came to us, when we were looking at building Atlas, and said, look, it's not that we don't understand MongoDB. We've got, 2 or 3 or 4 engineers who are really smart and they understand most of the stuff. But the thing is, we don't want to be in the business of managing shards and replica sets and doing patching, and we'd much rather have the focus be on developing our apps and sort of innovating the stuff that we're really good at. Like, wouldn't you all be the best at telling us how the performance works and making it work, and by the same token, the security? So on Atlas, for example, out of the box, there's no internet access. It's automatically TLS. You can't turn that off. You've got to set user roles and accounts, and then you automatically have high availability, even on the least expensive kind of accounts. And so that's great. It makes a lot of things go away. What's trickier though is to go from there's that old cartoon about how to draw an owl, where there's first there's an oval, and then there's like a second oval, and then the next picture is like a fully fleshed out owl with like the finely done feathers and the eyes and everything. Like, it's that step in between that's really hard. It's operationalizing it with real data. And so if, a lot of developers tell us it just makes more sense to have that as a managed service. But if you need to go down that route of having of doing it yourself, there's just a lot of pieces to put in place.
No, it's a good answer to the question, I guess. But so, I mean, it comes down to this: people want to feel comfortable that okay, look, all cards on the table. We're gonna say, I'm gonna edit that afterwards. So what I wanted to ask you, Ken, was MongoDB has some historical challenges with that dichotomy between making the database easy to use and making it secure. And some may say that the decision was made at some point to make it more easy to use than secure. And what I want to ask you is, can people feel comfortable today using MongoDB in the cloud? You mentioned that MongoDB Atlas is secured through a number of ways, but talk a little bit more about how you've solved that question and how you can answer that to folks.
Oh, sure. So yeah, I mean, this points to sort of a major misconception, which is, I think if you kind of distill it down, or if to be like completely reductive, you will hear from time to time, well, MongoDB is not secure. So to that, what I'd say is take an RPM or Debian package or what have you, from the distros, download it, put it on a public facing, internet, cloud server. If you can compromise that, we'll give you $10,000. We haven't had remote exploits in something like 5 or 6 years. If you change the defaults to allow internet access, but you don't do the next step, which is to run these 2 or 3 lines, which of script to set an application password, then yeah, that's a problem. But there's a problem for any system, for any database. With Atlas, we just don't even give you the option. You have to set auth, and so the trade-off we made on the on the self-install, on the standalone version is the out-of-the-box configuration is reasonably secure. If you change that, then you can't go halfway. You have to, if you do a custom install, you can't sort of expose yourself to the internet because it makes your web server be able to talk to the DB, but then leave that wide open. And we see that quite a bit. There are very few architectures where you should ever have unrestricted internet access to a database. In general, that's really, really a bad practice and a code smell and a security smell. Sometimes we'll have the developer say, well, it's a mobile application, so I need to have, I don't know where people are connecting from. Well, no, then you have a proxy endpoint, then you have an API service endpoint, but it's a web service endpoint. You shouldn't have your database exposed directly to the internet. For the same reason you shouldn't have SQL Server or Postgres or Oracle or anything else, or a cloud bucket exposed directly to anyone if it's got sensitive data. So, we've done a lot of kind of work behind the scenes that I don't think has ever been recognized. So, I mean, I can spend a minute or two kind of talking about that if that's, if you think that might be interesting. Because I do think there's sort of a deeper security story that people may not be aware of.
I have a question maybe related to this, and if it means digging in deeper, then I would love it. So you mentioned the whole 777 permissions, and even though that you shouldn't do them, you could do them. If we look at that and take it to say MongoDB Atlas with the whole safe listing of IP addresses, or even giving user accounts access to certain things, I mean, are we doing anything right now to kind of deter people from doing that? Because I think if the user really wanted to, like you said, they could open it up to the entire internet, or they could create admin root privileges on all of their MongoDB accounts, right?
That's right. Yeah. So this is always the interesting trade-off with a service, a cloud service, or really any kind of service. You want to give people flexibility, but you also kind of want to try to provide as much safety net as you can to not shoot yourself in the foot. So yes, if you go into Atlas, spin up a cluster, name it, put some data on it, and then open up the the network ports, we will have a giant red flashing warning sign, and you'll get periodic emails that says, hey, by the way, this is a really bad practice. What we don't allow you to do is just to not have authentication. So you've got to set some kind of auth. So either a random token that you create, or a reasonable password, or at the absolute bare minimum. If someone is bound and determined to make to put risky things in place to make things faster, there's going to be ways to do that. We try to make that as hard as possible. And so I'm sure people are aware of these like criminals and things that were scanning GitHub, and they were looking for cloud tokens, API tokens. Because what would happen is people would get their AWS bill or Google bill or whatever, and it'd be like $20,000. And so what happened was they'd unintentionally committed, their API keys for like root access to their cloud accounts somewhere in like a hidden directory or an environment file or something, committed that to GitHub, to a public repo, to Gitbucket or whatever. Someone come along and taken that and then spun up a bunch of Bitcoin miners and so forth. So there were kind of like a lot of high profile stories, of a handful in the beginning, and eventually the cloud providers kind of got together and they said, look, we're just going to work directly with GitHub. We're going to work directly with Gitbucket and and programmatically scan these things. And so by the same token, now if that happens, you'll get a really nasty letter from Amazon or Google saying, hey, you did this, probably wasn't intentional, but by the way, we're going to cut you off if you don't address this. We get it ourselves from time to time because we're a large organization, and developers do all kinds of throwaway sandbox keys or things like that they're not really tied to anything at all. Sometimes they've been invalidated for a long time, but if they look like an access token, they'll pick it up. But some of the things that we have been doing too, we can't stop people from putting a blog on the internet that gives really dangerous instructions on how to stand up a server. But we've literally gone to random bloggers on the internet or to Stack Overflow or some of these other forums where, people can go because it's sort of high, it'll be kind of high up in the search results for installing the system, and reached out to individuals and people on forums and saying, hey, this is a great post, but this section right here, you may want to point people to the white paper. You may want to add these extra 3 lines because this is really high risk. And we've had great response with that. And also, we'll get calls from time to time from journalists, reporters, or whatever that are like, here's some massive breach in India or Mexico, or here's passport photos or something, and it's on MongoDB, and it's like, well, they're not our customers, and it's just a random box on the internet. We're super limited on what we can do. We're certainly not going to start probing into someone else's infrastructure that we have nothing to do with. What we can do, though, is if we're made aware of it, if you can give us an IP address, we can do some open source research and find out at least if this is a public cloud provider, and if it is, we've developed relationships deep in the security teams at Amazon and Google and Azure, and we can escalate that to people to say, look, this has nothing to do with us. We're just trying to be good net citizens, but somebody somewhere out there is running really sensitive data insecurely on your infrastructure. And I know that at least in the case of Amazon, they will reach out on every possible contact you've ever given them for billing or whatever, and start, contacting people. And eventually, if there's no answer, they'll just cut it off. They'll just, cut off network access. And so, that tends to get people's attention. But we work with security researchers all the time who will find some breach or something, and sometimes reach out to us. And again, it's like, look, it's a general purpose database. People are going to do strange things with it. It's the story's not that it was a MongoDB. The story is that somebody held really confidential information and configured it in a bad way, and it got picked up by a search engine or a security researcher. And so, we've tried to make as much effort as we could, but it's a little limited in in terms of what we can do. But we've certainly made lots of progress. There's a whole story too about just in terms of how we build security into the products that I'm happy to get into if folks are interested, because I think it's actually some of the most sophisticated build engineering that I've ever worked with in my life. But I think it's another one of those areas where we're kind of a bit misunderstood.
Yeah. So what about the folks that say, we can scan the internet, we can scan and find these these insecure installations of MongoDB? Why don't you do that as MongoDB? Do you feel any responsibility for that? Why wouldn't you do that?
We don't scan the internet for database connections. It's one thing if someone has a web server that's offering content. It's another thing to go in with a direct wire protocol into a database and then start sniffing around and running random queries. They're two very different things. I mean, one is like, it's something's been indexed by Google and maybe it shouldn't be. The other is going out of your way to start, probing or trying to understand what's in someone else's system. That we just can't do. We're just limited. We certainly have relationships with, Census and Shodan and some of those folks. And actually they, the people who run those sites have written a couple of posts that said, look, this isn't specific to Mongo or Microsoft or Amazon or Oracle or there's a bigger story here. But so, if we're made aware of it, then, we'll help as best we can. But no, we're not gonna scan, infrastructure that's not ours, from databases.
You mentioned probing people's applications. So I want to ask a question around this. So commonly, at least with the relational database, people are sometimes opening themselves up to SQL injection attacks, right? They're not escaping characters, or they're not sanitizing the requests that come in, and that results in their database be given access to somebody, right? Does MongoDB suffer from any kind of attacks like that? Like, if you wanted to probe somebody, would you be able to? I guess is where I'm going.
Yeah, that's a good question. It turns out it's a little tricky. SQL injection in general is just one specific instance of unsanitizing arbitrary input data that's attacker supplied. So, on a web form or something, there's actually, I've got a few of these bookmarked in my files and things where people with, hyphenate or apostrophe last names like O'Leary would literally type their name and they'd get like a PHP error or a Python error or something. And it was clearly part of some kind of SQL thing. So the broader problem is if you allow, public input, unfiltered, attacker supplied or adversary supplied input to be queried against your database, that's a serious problem. In general, we haven't seen many of those kinds of attacks in general in the wild with MongoDB, partly because we use, partly because we use drivers that have parameterized frameworks. So rather than sort of arbitrary strings that come in, they tend to be parameterized, which is kind of the practice that people in the the PHP and Java world do. But if you've got an application that you've custom built that you're not using sort of a standard framework, and you're constructing strings from from web input boxes, and then allowing that to hit the database directly as a privileged user, you can probably create some some shenanigans. But in general, because of the types of languages that people use and the frameworks that they're typically using, we just don't see that a whole lot.
Mm. So there's protection from that type of attack where people are trying to inject commands into a database from unfiltered input. And then there's attacks where they try to get access to the data that's stored on disk. And we've got a couple of ways that MongoDB protects against that. One of them you mentioned earlier, field-level encryption. For the folks on the podcast that are listening in that may not be aware of it, can you give us a definition of what field-level encryption is and how it works?
Oh, you bet. So I guess the way I'd say it is I think in general, and even among like security people and fairly sophisticated tech people, I think there's like a broad misunderstanding or misconceptions of what database encryption is, because nearly every cloud service has some kind of quote encrypted database. But usually what they're protecting is something that's either only done for compliance reasons, kind of checkbox, that's not really operational security, or it's addressing a very specific kind of threat, which you probably don't have. So if so let me kind of start from the beginning, like kind of the different types of database encryption, and we'll get to FLE. In general, most of the big public cloud providers, when you spin up a virtual machine, you can basically check a box and say, I want, I want an encrypted storage. And what that does is it encrypts the operating system. It encrypts the underlying, volume of the disk. And that's helpful for a couple things. If you believe that it's a small little provider and that at some point that physical hardware is going to get decommissioned and then go on some shelf somewhere in a storage room, and then who knows, maybe end up on eBay or Craigslist, and you don't want people to buy those hard drives or SSDs and then see your data, yeah, that protects against it. But it's a very different kind of thing than like a developer's laptop where you worry about you losing it in a taxi or having it stolen or having your phone stolen. Because in those scenarios, a disk encryption is really helpful. But I'm not personally too worried about a rogue Amazon or Google employee selling a $3 hard drive on eBay. So why do people have that? Well, the other piece is fairly legitimate, which is these are, there are millions of these things spun up and down every day. You have no idea who was before you or who's coming after you as a customer with these cloud services. So if you write sensitive data to a disk, you want to make sure that when you release that back into their fleet, that some other customer will see, that the next customer can't read your data. And maybe that seems like an obvious thing, but it's absolutely not. And I can tell you at least 3 out of the biggest 5 cloud providers at some point earlier in their lifetime, didn't get that one right. I actually myself discovered it by accident when I was doing some work on disk encryption. I was scanning the low level volume, the SDA, the dev SDA in Linux speak, and started seeing like love letters. This was a couple years back, and like dating profiles and what were clearly passwords and things. So it does happen, but that's very different than I want something to protect from hackers, right? Because that's a very different kind of scenario. So we have to kind of define who those attackers are. Is it an insider? Is it a rogue admin or DBA? And so we had a lot of customers at Mongo that came to us. Some of these were big gaming companies that had huge infrastructure, or in the healthcare world, or in the pharmacy world, and in retail banking and investment banking, came to us and said, we've got applications that we're running on Mongo on your cloud service, and it's great. It's it's super suitable for analytic workloads, that kind of thing. But now we want to put treasury functions. Now we want to put currency exchanges. Now we want to put credit card information or other things like this, that the highest sensitivity kind of data. What can you do to kind of help us to protect that? Because it's not that we don't trust you like personally, it's that our risk profile as an organization, we can't afford the exposure of any kind of third party managing this sort of data. And so that's how we eventually came to build the FieldLevel encryption. So the key pieces with that, it's the full complement is called client-side FieldLevel encryption. And so what that means is that rather than do some gymnastics with decryption, encryption, and where you hand your keys to the cloud service and then we sort of take care of all that, this is different. This is it's sort of like in the with the secure messaging apps like Signal or WhatsApp. The idea is that it's end-to-end encryption, so that if anyone's intercepting or surveilling, or if there's any kind of leak on the network, or if the party who's holding the data is sort of in the interim, like in a temporary state before the next person reads it, it protects against that. So it's end to end, meaning I'm sending a message, and the only person who should be able to read that is the person who I'm sending it to, and no other person. It's very similar to that, except the difference is instead of two people on a phone, it's my application writes it and my application reads it, and no one else does. No DBA, no sysadmin, nothing. And your cloud service, like I don't want pinky promise as a service. Like I don't want just a pinky swear. I want technical assurance that this can't be done. And so what FieldLevel encryption does, the way we've implemented, is it encrypts it at the application before it ever leaves your network boundary. And so by the time it gets to Atlas, it's already encrypted. So if we were to have some sort of breach, if Amazon or Google or Azure were to have some sort of breach, however unlikely that is, or if there was some mistake and somebody were able to get credentials into your database, they would see nothing. They'd see gibberish. They'd see meaningless binary data that's not recoverable. So that's kind of cool. The second piece was we had customers coming to us saying, we have contractual obligations, or maybe we have compliance reasons, like in GDPR or the new California rules that say, because of consumer privacy rules, we need some technical assurance that, like, on demand, we can ensure that all records tied to a particular user are deleted. Well, that turns out to be really tricky, right, in most applications, because most applications aren't just, a couple of tables or a couple of collections. They tend to, once data get in, they kind of tend to sort of ferret their way into all kinds of different places in a system. But what FieldLevel encryption allows us to do is to say, fine, we'll just destroy the key that's tied to these particular documents, and those documents are now irrecoverable. It doesn't matter if you have backups. It doesn't matter what. If once that encryption key's been destroyed, that data are irrecoverable. Those data are irrecoverable. So FieldLevel encryption lets you encrypt an entire collection. You can encrypt multiple fields. You can even use a key on an individual document basis. And those are all customer managed. So those are keys that you can spin up on Amazon or Google or Azure, and you see and you hold. We never see them. They're never delegated to us, nothing of that sort. So again, by the time they get to the Atlas service, the database that we're managing, it's already encrypted.
So I have a question regarding this as well. So you mentioned destroying the key would destroy the records that exist in MongoDB. Are you suggesting that when people use FieldLevel encryption, they encrypt all fields within that document, or just certain fields?
No, that's a great question. Like a lot of things in security, there's trade-offs. You lose some functionality when you use client-side encryption. So, for example, you can't ask the database anymore. Pardon me. You can't say, "Give me every user at this specific time within, say, 5 kilometers of this geolocation." You can't do that because A, it doesn't know the geolocation; it only sees gibberish, and B, it doesn't know the other, the other geolocation. So anything that the central server would have to do, to have knowledge of the underlying clear text data, there's some limitations on that. What we spend a lot of time doing is to try to make it so that you don't have to worry about a lot of that. You should just be able to say, maybe I only need to encrypt social security number or a mobile number or a credit card number or certain types of health records. Because it turns out, if you think about it, if you had a big, like a financial database of customer accounts, the dollar value, right, the account balance itself, that's not sensitive. It's only sensitive when it's tied to a particular person. Otherwise, it's just sort of an arbitrary number. And so for performance reasons, you may want to have really high performant queries that are run against plain text fields. So you can sort of do this mix and match. But for the most sensitive fields, yeah, you'd want to use either what we call deterministic encryption or something called randomized encryption, which is the strongest kind of confidentiality protection. So if you're able to just query on, say, a customer ID or a user ID or something like that, we'll bring back the entire record back to your application, and then it's fully decrypted. But it limits, some of the operations you can do on the query side.
And what about performance? Does this degrade performance much?
So that's always a tricky question, and like most things, it sort of depends. So the way the short version is, in general, for typical web application loads where it's sort of 85% read, 20% writes, the performance impact's usually less than 5%. but it gets a little tricky because if you're doing massive writes, if you're generating thousands of keys, per minute or per second, then that does add some overhead. The way we've engineered this too, there's a separate service process that's running on the application server to help kind of parse queries, and so it turns out that with certain, like on the Linux side, with certain SE Linux things turned on, you actually can get quite a big performance boost by managing local sort of internal network security profiles. Anyway, we're kind of working on some production guidance for customers. But if you're familiar with something called the TPC benchmark, so it's this is kind of one of these classic. It's been around for 20 years in the relational world. Asia, one of our principal engineers, I think like a year ago, helped port the TPC sort of standard to a NoSQL kind of format where we could try to, as close as we can with sort of the equivalent spirit of what TPC was trying to do with the document model, give us some at least internal benchmarks that we can compare different workloads. So we're going through the process right now of, we've done some preliminary testing using the document TPC workbench, as well as the Yahoo Cloud, what's it called, the YCBS benchmark. So we'll be coming out with some very detailed performance papers on that. But in general, the hit on the server is minimal because it's sort of oblivious to the data. You can still take advantage of indexing and caching and all those sorts of things with the type of encryption called deterministic. So there's very little hit or impact at all on the server. There can be more on the client side where the application lives. But if you're already at the headroom of like 96% CPU and network utilization on the application server, then you're definitely going to feel it more. If you've got lots of headroom, which is usually the case on cloud instances, it should be really negligible.
Mm-hmm. So who's really excited about this feature? A couple of questions. I'm gonna load them up. So who's really excited about this feature from an industry perspective? Like who are the big industries really waiting for FLE? And is it available on Atlas, on the server? Is there additional cost associated with it?
Yeah, no, there's no cost associated with it. So it's available on Atlas today. It's available in the in the on-premise as well as the both the community and the EA. In the enterprise and in the Atlas version, you do get something called automatic transparent encryption. It requires this one additional kind of service file, and it lets you do things like sort of default to particular keys and have a little bit more. It makes it so you can reuse queries that you've already written without having to modify them. That was the other thing too, is when we first started looking at FLE, it's not that there's a lack of encryption options available out there. There's tons of software development kits in every language, and all the different cloud providers have it. The problem is you have to bolt them on, you have to modify all your queries, you have to change how you're doing things, and then usually you have to kind of get into and understand all the minutia of IAM profiles and the key management services. One of the things that we spent a lot of time doing was making it so that you don't have to do that. You can just plug in an access token and a key to the driver, and it sort of does the heavy lifting with the cloud management. So all the the core cryptography frameworks, all open source, Apache license, available on GitHub. But yeah, so it's available anywhere Mongo runs, on GovCloud, Atlas, self-managed, on-prem, or even on your laptop. In fact, we built it in a way for developers so you don't even need internet access. You can use a local key store, or do a web service call locally or remotely, I guess, to access the encryption keys.
So in regards to field level encryption, and I apologize if I missed this, but I just want to get some clarity. Are we implying that if you choose not to use FLE, that your data is not encrypted or secure in MongoDB at rest, or is this totally something else?
No, they're kind of addressing separate things. So Atlas assures you that you're always going to have encryption anywhere the traffic moves on the network. You're always going to have encryption on the operating system itself. So, without access to those encryption keys, someone couldn't take an image of your, like a snapshot of your virtual machine instance and see anything from that. If in addition you've done the BYOK, what we call the encrypted storage engine, on top of that, even if you were an administrator or a sysadmin or a DBA, without access to those keys as well, you wouldn't have access. What FLE provides is that the most privileged person, even if you had views into process memory and were able to inspect anything, any active process on that machine, that's what field level encryption protects. So it's the highest level of confidentiality that you can provide. But no, even in the baseline scenario, there's quite a number of encryption layers that are built in, sort of just that come by default.
So I think I have one more question for you. Then I'll leave it over to Mike. I know a lot of organizations, particularly in maybe government or medical, they are heavily dependent on certain compliance codes being met. So I think like healthcare is HIPAA. I think with education it's like FERPA. What kind of compliance does MongoDB offer? So that way people who are kind of looking at MongoDB can get an idea if it's going to be suitable for their organization.
If you just go to mongodb.com/trust, we have a whole link to all the all the compliance frameworks and either attestations or independent assessments that we've taken. So specifically some of the questions you asked. So HIPAA for workloads on Atlas, we do issue BAAs if those are needed. There's a whole suite of things around SOC 2, around the internal controls of our personnel and how we do that. Atlas is PCI certified, so we've got a whole suite of controls around that's audited and updated, frequently. There's a number of different compliance frameworks. We're being used in the GDPR, to comply with GDPR regulations by a number of customers. As I mentioned, some of the direct, retail pharmacies and healthcare, some of the biggest insurance providers, they're all running on Atlas. So yeah, there's quite a few different kind of compliance frameworks in place that we're happy to share more with if that's useful.
Great. Kenn, I want to thank you so much for spending the time with us. It's the hour has gone by so quickly, but before we give you back, what else would you like to tell the folks that are listening in on the podcast? Any plugs that you have personally, or parting words of advice for the folks listening in?
I think what I would say is just go take it for a spin. I mean, I think there's just a lot of misunderstandings. It's easy to get up and going. If Python or Java or Scala are your jam, then we've got tutorials for that to get you up and going. We've got basically hello worlds for the FLE if you want to try something in Python or Node, and just
where can I send people for the hello world or the driver examples?
Yeah, so just on our, let me see what the quickest version would just be to Google for FLE, FieldLevel Encryption for MongoDB. It's in our security documents, but there's some nice tutorials that literally have tabs for if I'm using Java, or if I'm using Python, or if I'm using C#. You just click the tab and it's like, here, create the key, here, create a couple simple fields, here's how to do the query, here's what it should look like coming back. So really straightforward. We could post a link, I guess, in the description for some of the other Hello World examples, but we've got it for all the major languages. So even if you just wanted to play within the MongoDB shell, without having to write code, in sort of a normal language framework, you could do that as well. We've got some examples you can just plug in and copy and paste and go.
That's great. Terrific. Well, once again, Kenn White, thanks so much for spending the time with us. Appreciate it.
Thanks, Kenn.
Great chat. Thanks, guys.
Thanks, everyone, for tuning in. If you enjoyed what you heard, head on over to your favorite podcast network and be sure to give us a good review to let others know what you enjoyed. If you'd like to meet and interact with other folks on the MongoDB community, be sure to head on over to community.mongodb.com. And if you're a startup and you're interested in leveraging FieldLevel Encryption or any aspect of the MongoDB platform, head on over to mongodb.com/startups. Thanks for tuning in.